Hi, I'm Dr. Jason Brinkley, and this is Avogadro's Law at molar volume and density. By the end of this video, we will be able to describe the behavior of gases expressed by equations to calculate changing conditions, and we'll use molar volume and standard temperature and pressure, STP, to perform calculations. So Avogadro's Law is what the mole is based on. It is basically stated that if you have twice the number of particles, you need twice the volume in which to keep them at the same temperature and pressure. Or volume and amount of gas are directly proportional at constant temperature and pressure. In other words, V1 over N1 is equal to Avogadro's constant. So this is the concept of the mole. Equal volumes of gases at constant temperature and pressure contain the same number of particles. Under changing conditions, V1 over N1 is equal to V2 over N2, much like Charles's law. So let's do a problem. A 1.00 mole sample of hydrogen gas occupies 22.4 liters. How many moles of hydrogen are needed to fill a 100-liter container at the same temperature and pressure? So for part A here, we've got V1, N1, N2. So we've got volume 1 is 22.4 liters. N1 is equal to 1.00 moles. V2 is equal to 100.0 liters. And N2 is equal to what we're looking for. So we're going to take V1 over N1 equals V2 over N2 and solve for N2. When we do that, we get N2 is equal to V2 N1 over V1, 0.0 liters times 1.00 moles over 22.4 liters. And when we do the math on this, we're going to get 4.5, or actually 4.46 moles of gas, moles of hydrogen. We can also do the next problem, part B. How many moles of hydrogen are needed to triple the volume occupied by 0.25 moles of hydrogen, assuming no changes in pressure or temperature? So for part B, we're going to take V1, N1, V2, and N2 again. And how many moles of hydrogen are needed to triple? So we're looking for N again. And we've got N1 is equal to 0.25 moles of hydrogen. Now they don't give us a V1, they don't give us a V2. But it's saying the amount tripled. So why not just say 1.00 liters and 3.00 liters? Because that's tripling the volume. So V1 over N1 equals V2 over N2. Solve for N2 again. Gives us N2 equals V2 N1 over V1, which is equal to 3.00 times 0.25 over 1.00, or 0.75 moles of hydrogen gas needed to triple the volume. Now, some interesting things happen. 1 mole of any gas at standard temperature and pressure, remember standard temperature and pressure is 1 atmosphere and 273 Kelvin, is going to occupy a volume of 22.4 liters, always, which means this is basically a conversion factor. Okay, so if I know the number of moles at STP, I can find the volume at STP. And then I can do anything I need to from that using the combined gas law or Boyle's law or Charles's law. Also, what comes out of this is density of gases. Since the density is mass over volume, we can calculate the density of any gas at STP by taking the molar mass and divide by 22.4 liters. So, let's ask the question, what is the density of carbon monoxide gas at STP? Well, the molar mass of carbon monoxide is equal to 12.01 plus 16.00, or 28.01 grams per mole. We're going to take that 28.01 grams per mole over 1 mole of gas is 22.4 liters, and that is we're going to get rid of that. We know that the 1 mole is there, so it's 28.01 grams. So 28.01 grams divided by 22.4 liters gives us a density of 1.25 grams per liter. That equals the density. So as you can see, Avogadro's law is very useful when it comes to knowing moles and volumes and to calculate things at STP. But if we're not at STP, we're going to need something else to do. We're going to need another equation. That's where we come in with the ideal gas law, and we'll talk about that in another video. I hope you've enjoyed this, and I look forward to seeing you in the next.